When you finish this lesson, you should be able to find the distance between 2 points either on a number line or in a coordinate plane. So first we're going to talk about finding the distance on a number line. And what we're going to do is we're going to subtract the 2 points from one another. And as long as we find the absolute value of that, it doesn't matter which point you write first. All right, so it wants us to use the number line to find each measure. When it says then find the measure of BD, that means find the length of the segment BD. So from point B, which in our case is -7, to point D, which in our case is -1. So minus a -1. And we want the absolute value of that. Again, you can write the -1 first or the -7 first. Because we're doing the absolute value, you'll get the same thing. -7 minus a -1 is -7 plus 1, which is -6. So the distance of those is 6. If we want to find the distance of DG, D is -1, G is 8. So we subtract those and find the absolute value. So -9, which would be 9. If we want to find the distance between A and F, so how far is AF? A is -9, F is 1. Oh, is F 1? No, F is 3. F is 3, which is -12. So their distance is 12. If I want the distance between E and F, or how long is segment EF, E is 0, F is 3, that's going to be -3, and the absolute value is 3. Now, you can also just count. So let's go back to AF since I like to say that. If I count the distance between A and F, I should get 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why did I say you should get 9? You should get 12. The answer is 12. Okay, so I can just count the distance as well. So if I want to find the distance between BD, that should be 6. 1, 2, 3, 4, 5, 6. So you can always just count the distance on the number line. Where the subtraction comes in helpful is like if we had like huge distance. So like if B was at -1,246 and D was at 5, you don't want to count 1,000 some spaces. So that's where the subtraction is easier. But since we're in a more limited space, you could always just count that distance as well. If we're on a coordinate plane, we can use what's called the distance formula. And the distance formula is just using the Pythagorean theorem. Okay, so let me show you how they get the distance formula. So here we have a line, and it is at point x1, y1, and the other point is at x2, y2. And those don't mean squares. So this little subscripts that you see there, that doesn't mean square, that just means the second point. Okay, that's just the second point. It's kind of like when you did slope, and it's y2 minus y1 over x2 minus x1. So if we draw a right triangle connecting these points. So if we draw a right triangle connecting those points, if I want to say, hey, what's the distance here? It's, well, in our case, it's 3. But it's the distance between y2 and y1. The distance between y2 and y1. And remember, Pythagorean theorem, you square the legs squared. So that's like b squared. If I want to know how far this distance is, it's going to be between x2 and x1. Okay, x2 and x1. And again, that would be like a squared. And if you remember from those problems that we were doing with Pythagorean theorem, if I do the square root of that, it'll give me the hypotenuse. Okay, so the distance formula is just the Pythagorean theorem. Okay, so again, because this is like b squared and this is like a squared, and then we're doing the square root of it. So it's just really using the Pythagorean theorem. So we're going to find the distance between these 2 points on the coordinate plane. All right. So what we're finding, if you look down below here, we want to find the distance between 0, 0 and the 0.68. So I graphed it in Desmos. So we're trying to find how long is that and how many units is that. I'm going to write the distance formula here just because I don't have it on my screen. And I like to look at it while I'm filling it in. So it's not something you have to write. This is just for me. So x2 minus x1 squared. So my x coordinates subtracted squared plus my y coordinates subtracted and squared. All right. Then I like to look at my example and I like to label. So x1, y1, x2, y2. And then I go ahead and I just fill in the formula. So the square root, all right, and then the first parentheses are my 2x coordinates subtracted. So x2 minus x1. And the next parentheses is my y coordinates subtracted. So y2 minus y1. Okay. 6 minus 0 is 6. 8 minus 0 is 8. Okay. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. And the square root of 100 is 10. When you do these problems, the order, it's kind of like, it's using that order of operations. It's very important that you go in the correct order. So you do your subtraction in the parentheses first. Then we take care of exponents. Then we add them together, and then we do the square root. Okay, so we make sure we're doing it in that order. Now, if we go back down here to where I graphed them in Desmos, again, to graph in Desmos, you just type in the points. You can do this on graph paper as well. You can just use the Pythagorean theorem on these if that's what you're more comfortable with. So I count the spaces going this way. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. And then the spaces this way. 1, 2, 3, 4, 5, 6. So again, 6 squared and 8 squared. That would take me straight to this step right here. Okay? So if I do the Pythagorean theorem version, I can just graph the 2 points and count. And again, you can use Desmos to graph if you want, if you don't have graph paper, and just count those spaces. Okay? So, distance formula, Pythagorean theorem, they're the same thing. Okay? So let's look at example 10. Again, I'm going to label x1, y1, x2, y2, square root, squared, squared. So let's see, y2 minus y1. Notice it's minus a negative, which is plus. Okay? And then y2 minus y1. Alright, just like I said, 3 minus a negative 2 is the same as plus. So that's going to be 3 plus 2, which is 5, squared. And then 15 minus 3 is 12, so 12 squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169, which is 13. So the distance between those 2 points is 13. So that's from here to here. Again, I can use Pythagorean theorem. This is 1, 2, 3, 4, 5 spaces. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12 spaces. So there's my 5 squared plus 12 squared. Again, whichever method floats your boat. All right. So number 11, we're going to do pure distance formula, and number 12, we're just going to use Pythagorean theorem. Okay, so we can make sure we have an example of both. So again, x1, y1, x2, y2. For some reason, I've got to have the distance formula sitting in front of me to be able to fill it in, and I think you might not need to, but that's just me. All right, so x2 is 9, x1 is 1, y2 is 13, minus a negative 2. 9 minus 1 is 8, so that's going to be 8 squared. That'll be like plus 2, so that'd be 15. 8 squared is 64. 15 squared is 225. So that's 289, and the square root of that is 17. So all these have whole number answers, but I'm pretty sure, let me look. Yes, your classwork will have decimals in them sometimes, so when it does, when you do square root and you get a decimal, let's go 2 places. All right, so number 12, we're going to do pure Pythagorean theorem. So I'm going to draw the right triangle there. Notice I go all the way here into there. Okay, this is 3 spaces. This is 4. So I'm going to do the square root of 3 plus 4. Oh, that's one of our Pythagorean theorem triples. I know it's going to be 5, but we'll go through it. 9 plus 16. 9 plus 16 is 25, and the square root of that is 5. So again, distance formula, Pythagorean theorem, does not matter. All right, so what you're going to do is you're going to complete the next side of the sheet, or the next sheet. So it'll be 1 through 10, and then 1 through 12. Okay, so if it's just on the number line, then you can do that where you do the absolute value, subtracting the points or count. And then if it's on the coordinate plane, you can do Pythagorean theorem, or you can do distance formula.